Okay, 14.6. Number one, graph the function f of x equals x plus 2 squared minus 1 using your knowledge of f of x equals x squared in translations. This is actually pretty simple. They're going to give you sort of a graph that looks something like this with 3 dots on it. And basically all you're going to do is this, what we call the vertex. You're going to move this. So the way that you move it depends on the function that they give you. And here you're going to sort of do the opposite. This is a left-right movement here inside the parentheses. You're going to go left. Even though it's plus 2, and you would normally think you're moving to the right 2, here you're going to move left 2. And this number that's outside the parentheses is an up or down one. So here you're going to go down 1. So you're basically going to move that vertex point. You're going to move it left 2, down 1, and that's the end of that problem. Move it left 2, and then down 1. Number 2 and 3, find the vertex of y equals 9 times the quantity x minus 9 squared plus 10. This is also pretty easy when you're looking for the vertex. Basically, if you've got an equation that looks like this and you've got some things in parentheses squared, and then you've got a constant out to the right of it, basically your vertex is going to be the opposite of this. So 9 on that one. And then you're actually going to use whatever that number is. So your vertex is going to be 9, 10, and that's the end of it. This example number 3, find the vertex of y equals negative 1/2 times the quantity x plus 2 squared. Here, doing the same thing. We still want the opposite of this number that's on the inside though. So instead of 2, you're going to use negative 2. And where up at the top we had positive 10, here you have to imagine sort of an imaginary plus 0, which doesn't exist there. Really, it's not written explicitly, but that'll give you your second value. Whoop. And then that's your vertex. So negative 2, 0. Okay, number 4. On the next few examples, number 4 and number 5, there's 4 steps involved. So we'll start with step number 1. Find the vertex of y equals negative x squared minus 3. This is not that bad. You just have to keep in mind that on the previous examples where we found the vertex, we had a parentheses that was squared, and we had some x minus something or x plus something inside the parentheses, and that helped us determine what the vertex was. Here, you don't have a parentheses, but we can create one if we make this instead y equals negative, and instead of x squared, we're going to make it x plus 0 squared. Still the same as x squared because x plus 0 is just x. But this will help us figure out what our vertex is. So again, we're going to use the opposite of whatever the number is inside the parentheses. The opposite of 0 is just 0. There's no opposite to it, really. And then the negative 3. So line of symmetry, just like the last example, pretty easy. It's just whatever this first value of x is. So x equals 0. And make sure when you enter this into the computer that you put the x, you put the equals, and you put the 0. X equals 0 is the answer. If you just put 0 in, it's going to count it wrong. Step 3, determine 2 points on the graph of the parabola other than the vertex. And as we do these, you'll want to hold on to what your vertex is. And it was 0, negative 3. So we want to find 2 points on the graph besides the vertex. So what we're going to do is our line of symmetry was x equals 0. So we want to use an x value above, or let me say below rather, because we'll do below first. A value below and then above this. So we're going to use x equals -1. That's going to be our below. And then x equals +1, which will be our above. So below 0, -1, above 0, +1. So still using our same equation, which was y equals -x² - 3. But we're going to plug in -1 for x. So we've got a minus in front of -1 squared minus 3. So -1 squared is just 1, so we've got a minus in front of 1 minus 3, and that gives us -4. So your ordered pair for this, and you'll need to put an ordered pair in. We plugged in -1 for x, that was back at the beginning, and then we came out with -4. And by the way, just to make this a little bit easier, if you go just 1 below and then 1 above, the way this will end up working out is you'll end up with the same value that goes with your +1. So +1 and then also -4. So you can go through the process of substituting that 1 into the equation, but you don't need to. And as far as graphing the function, that's fairly easy. Just plot the vertex, which was 0, -3. And one of these points from step 3. Number 5, step 1, find the vertex of y equals 1/3 x plus 5 squared minus 5. Again, vertex hopefully is going to be pretty easy. Anytime you've got a parentheses that's squared, we're going to use the opposite of this. And then going to bring that down. Not going to change the second number, but -5 and then -5. Your line of symmetry, again, x equals, and then just whatever that first number is. So in this case, x equals -5. Again, make sure you put that whole thing in. X, and then the equals, and then -5. Okay, step 3, determine 2 points on the graph. Again, this is other than the vertex. So that vertex was 5, -5, 5. We want to make sure we're getting different points than that. So we want to use something above this number. So we're going to use, rather below it and above it. So below it would be -6, and above it would be -4. So we're going to plug both of those numbers in to the equation that we started with. Not going to need to do it with the -4, because whatever number we get to go with the -6 is going to be the same thing that goes with the -4. And we'll start with the equation y equals 1/3 x plus 5 squared minus 5. And this time we're plugging in -6 for x. So let me go ahead and erase that. Plugging in -6 there. And then we'll go through this process. We've got y equals 1/3. And then -6 plus 5 is -1. We want to square that and then subtract 5. So we've got y equals 1/3. And then -1 squared. -1 times -1 is just +1. 1/3 times 1 is 1/3. Then we want to subtract 5. And so if we're going to put 1/3 and -5 together, we need a common denominator. You might keep in mind that the 5 has an invisible 1 on the bottom of it. So our common denominator is going to be 3. So for the first one, 1/3. And then in order to get the 5 over 1 to a denominator of 3, you've got to multiply by 3. Multiply the 5 by 3 also, so we end up with 15 on top and then 3 on bottom. And then if we do that subtraction, 1 minus 15 is -14 over 3. And since we started with the -6, that was our x. and we came out with a negative 14 over 3. That's going to be one of our ordered pairs. And then the other one, negative 4, and then the same, negative 14 over 3. You can plug that in to see if you get that same thing, but if you do it, that's what you'll get. So we've got both of those points there. You'll enter both of those in for step 3. Step 4 is a little bit different from the previous one. You'll still want to plot the vertex. So plot negative 5, negative 5. And on the last one, we just use the points from step 3 in order to graph this. But if you look at these, 6, negative 14 over 3 is going to be a difficult thing to graph with the graphs that we're given on the computer. So what you'll need to do is, there's a few different methods you could use, but I've tried to abbreviate the process as much as possible. And there's a little trick that you can kind of use to come up with a second point to this one. And what you'll do is, starting with the original equation, y equals 1/3 negative 6. Initially it was x plus 5 squared minus 5. What you can do is, instead of using x, you can plug in, here we've got 3 and we've got 5. If you subtract those, so enter, or I'll say use negative 2. And all I've done to get that number is to take that 3 that's there on the bottom and subtract whatever number is there. So we're going to go with y equals 1/3 and then 3 minus 5, which is negative 2 plus 5. Going to square that and then subtract 5. So hopefully that doesn't seem too confusing. There's other ways you could plug in random values of x, and then hopefully you'll get some things that don't end up being fractions like this that you can graph on the computer. But this way you should end up with something that's easy to plot. So 1/3, negative 2 plus 5 is 3. You want to square that, minus 5. 1/3 times 3 squared, which is 9. And then 1/3 times 9 ends up with 9 over 3. 9 over 3 is just 3 minus 5, and you end up with negative 2. So the ordered pair that you get out of all that is, we had negative 2 for x, and then we ended up with negative 2 for y. That's just a coincidence that they ended up being the same, so don't just assume that they're going to be the same. They won't always be. But basically what you'll do is you'll plot negative 5, negative 5, and then you'll also plot negative 2, negative 2. One more note before I conclude this video. If you're given basically the same equation, 1/3 x minus 5 squared minus 5. On step 4, you'll still use the vertex. You still would use the vertex. Negative 5, negative 5. And then when you're looking for something else to plug in here, 3, and you're going to subtract that number. So 3 minus negative 5 in this instance, which comes out, 3 minus negative 5 is 3 plus 5, which is 8. So you're going to use that for x. And then, so 1/3, 8 minus 5 squared minus 5, and then 1/3. Still end up with 8 minus 5, which is 3. And it should work out roughly the same.